Hello, in this video we're going to take a look at some applications involving exponential functions. Our first one, we have a single pane of glass obliterates 5% of the light passing through it. The percent P of light that passes through n panes of glass can be approximated by P of n equals 100 times 0.95 raised to the n. So what percent of light will pass through 10 panes? Well, all we're doing here is we are going to plug in n is the number of panes, so we're just going to plug in 10 for n. So P of 10 is 100 times 0.95 to the 10th. So if we look at that, 100 times 0.95 raised to the 10th is 59. Let's go ahead and round this off to the nearest percentage, so that'll be 60%. So 60% of the light is going to pass through those 10 panes of glass set up next to each other. All right, what percent of light will pass through 30 panes? So we're going to do the exact same thing. We're just going to plug in 30 instead of 10. And so on the calculator, we can do second enter to pull up the last thing we typed in and just change that 10 to a 30. And we get, let's see, that'll be 21.4, 21 and a half. So 21% if we keep rounding to the nearest integer. So 21% of the light is going to make it through all 30 panes. So what is the meaning of the base of 0.95 in this problem? Well, if 5% of the light is obliterated, it's absorbed in, reflected off, whatever the situation may be, 5% of that light does not make it through the pane of glass. So this is telling us everything that's left, that means 95% of the light comes through each pane. All right, another similar setup. Here we have the price P in dollars of a specific car that is X years old is modeled by this function. P of X equals 22,625 times 0.88 to the X. So a 4-year-old car, well, X is giving us the years, the age of the car in years. And so a 4-year-old car, we're going to plug in 4 for X, so we get 22,625 times 0.88 raised to the 4th. Again, plug it in the calculator. When you do that, you get 13,568. So this is our price in dollars, so our units here are in dollars, 13,568. And a 9-year-old car, we're doing the exact same thing. We're going to plug in 9 instead of 4. So when we plug in 9 there, second enter is going to pull up the last thing we typed in. We can go change that 4 to a 9. And we get $7,160. All right, so if we want to, our last question here is, what is the meaning of that base of 0.88 in this problem? And what that is giving us, similar to the last one, it's only going to be worth 88% at the end of that year. Just like the light is only 95% of what it was going in, so the car will be worth 88% of what it was worth last year. Another way of saying that is it will lose not $12, but 12% of its price each year, or of its value each year. All right, I'll see you guys next time.